Hola, chaps. Let's learn. Hola, chaps. Mr. Turek here. This is Charging Objects Part 2. So to recap, I have this handout called Charging Objects, and it begins with a balloon, and I charge the balloon, and I carry out some experiments that verify, yes, the balloon is positively charged. Neutral objects become polarized and attract to this charged object. So that is a form of charging. It's without directly touching the charging object. I didn't make that too clear, but okay, more teaching to be done. Then there's charging by touching, which was the bottom of this handout. And now I'm ready to move on to the back side of this handout, which deals with a PVC pipe and a piece of wool. We have a supply of these in our classroom, and normally you would get together with a partner and have these materials and this worksheet. Of course, I have to do this for you now, right? So here we go. This is irrigation pipe, PV stuff you can get from the store. You might have some around your house in your garage or so. You don't have to use this. You could use a plastic ruler. I think that would do the same job. And someone once donated some article of clothing, and we chopped it up. And so here's the wool that we've been using for several decades. And let's work through the worksheet, or watch me work through the worksheet. When you have two neutral objects, I'm reading the text that you can almost see, you can charge the two objects by rubbing them together. Rubbing the objects together gives energy to the electrons and allows them to move. Okay. Let me just read it. They will always move toward the material that has room for electrons and lower energy levels. Plastics tend to give away electrons to take on a positive charge. We actually have a textbook for a physics course, although it's probably a doorstop in your house right now. And in the textbook, there does exist a table that says, okay, this material tends to become positively charged, that material tends to become negatively charged. And sometimes we ask our students to sort of memorize that table, but not this time. For now, the one thing to memorize is that if I have a plastic pipe, and we're going to call this plastic, there's different types of plastic, there's ABS, PVC, dot, dot, dot. So for this plastic pipe, when I charge it, well, let's just go into drawing. So I have what is initially a neutral piece of plastic pipe. So to show that it's neutral, I would have to draw a checkerboard pattern alternating plus and minus. Now it turns out that this is so narrow that it's just going to be a linear checkerboard pattern, right? So a plus, a minus, a plus, a minus. And that's the very minimum that I would draw that shows that it's both neutral and not polarized. Polarized would mean all of positive charge on one side, all of negative charge on the other. But this is neutral and not polarized. This rectangle represents the piece of wool. So long, skinny rectangle for the pipe, rectangle for the wool. See how it totally matches the drawing? Excellent. So to show that it's also initially neutral and not polarized, I would do a checkerboard pattern on it. I will rotate mine because what the heck. There, neutral, not polarized. These are the two materials that I have to start off with. Then, when I rub them together, so it says by rubbing them together, I'm giving energy to electrons. I'm giving them the opportunity to move if they want to. Okay, so I'm going to start rubbing these together and watch magic before your very eyes. Science at work. So yesterday was a rainy day here, and this would have been a terrible, yesterday would have been a terrible day for demonstrating this because the humidity in the air affects how well these demonstrations occur. But today the sun is shining and it's blue sky as I look out my window, and it's a much better day for doing this sort of demonstration. So yes, okay, yes, am I teaching how to do this? Yeah, fine. So here is the rod, and here's the wool afterwards. And when you look at them, they look unchanged. There's nothing you can see visually looking at this that would look any different in before compared to after. But it says, charge up a pipe with wool, and it says it becomes positive. So there's the answer key to you. This being plastic, plastics tend to give away electrons to take on a positive charge. So what I should be drawing in this middle sketch here, so this is before, during, or middle sketch and after, right? So during, what's going on? The plastic should be giving away electrons. So I should take a symbol for an electron with an arrow showing that it's transferring over onto the wool. Okay, so that's what's going on. The electrons are transferring over onto the wool. And therefore, afterwards, what's the net overall charge on these things? Well, there are still positively charged protons everywhere. And I think what I'm going to try to do is just have you emphasize, so what's the net charge overall? So if the plastic pipe gave away electrons, what's left behind are positive charges. And what's the net charge on the wool now is the wool overall is now negatively charged. Now, in past years, I'd be a little bit more picky about exactly what you draw and, still show that there's protons in both places. However, this year, you're happy to just have me do all this for you, right? So it says charge up a pipe with wool. It becomes positive. So as if, you don't know the answer key, there's the answer key. And it says hang a pith ball from a ring stand with string. I brought home a ring stand from school 2 months ago, knowing that someday I would do this activity for you, but I can't quite find it. So the other thing I did, just in case, is I brought home a whole bunch of VEX parts, they're called, from our engineering lab. And so I just built a ring stand. Ta-da! Here it is. So it has a simple job. That represents my pith ball. Now, it's not a piece of cork. It's just a Cheerio because once I read that Cheerios is a healthy choice for breakfast meals and that. Anyways, I have Cheerios. Ha! It's string hanging by a thread. And as you can see, it's free to move. Whoop, there it goes, moving. And in the name of science, I don't think you need to see the overhead camera doing anything. I suppose I could try to optimize it for this viewpoint, maybe make it go like this. And so now you have a top-down view looking down along the length of the thread, and it's showing up on this monitor here. And meanwhile, live view, you see what's going on there. So here's my PVC pipe, plastic pipe, my wool, and just in case, I'm going to recharge it. And I can hear little snap, crackle, popply things saying, oh, those are electrons. Okay, so this thing I claim is now positively charged, and I bring it near the pith ball. What happens? Okay, so you can see, it's not me doing the wind or anything. You can see that this Cheerio was attracted to it. Okay, was attracted to it. But now notice that it's kind of pushing away from it. Well, now it's attracted and it's pretty happy. And now it's pushing away. So can you explain all that? You should be able to explain all that. There's nothing more I need to do by way of teaching. It's now critical thinking skills on your part, and you should be able to fill in the rest of the worksheet and answer for yourself exactly what you see, observe, exactly what you observe happening. So notice that I have situations where the Cheerio sticks to the plastic, and after that, there's situations where the Cheerio repels from the plastic. Sometimes it sticks like this. It's sticking a lot until the force of gravity becomes stronger than the electrostatic force of attraction. And I'm going to let it stop its swinging back and forth, although that takes us back to the mass on a string simple pendulum lab from physics. You used to be able to calculate, oh, for this length string. Anyways, so the point is there's science everywhere. The Cheerio is sticking to the PVC pipe, plastic pipe, and under some conditions, I can get it to, instead of attracting to it, after it touches it, right now I'm not getting it to do that, but eventually I can get it to not only attract, but afterwards repel. Not happening in this live demonstration. Oh, well, let's talk about what should happen, right? So what should happen is There we go. See how it jumped away all by itself? That wasn't me giving it a bump. Replay that video 6 times if you need to. Let's just say that's what I'm trying to show you. And fill in the rest of the worksheet. Here we go. So what was the charge on the rod at first? It's a positively charged rod. What's the charge on the Cheerio before it comes near the rod? So that guy just sitting there by himself enjoying life, what was the charge on him? And you should say neutral and not polarized. So you should do a checkerboard pattern that says, oh, it's just a Cheerio sitting there. I wonder if it goes well in milk. Anyways, when held close to another, what happens? Well, they attract. So what do the charges do in the pith ball? They polarize, right? It's still neutral. So what I should be drawing is the rod is positively charged and the pith ball is still neutral, but now the minus electrons are closest to the pith ball and the protons left behind are farthest from, I said pith ball, from the plastic pipe. Okay, so the electrons are closest to the plastic pipe and the protons left behind after the electrons move out of that neighborhood is positively charged. Okay, so what type of charge does the pith ball think it has based on its behavior? Seeing that it is attracted to a positively charged object, it thinks that it has what kind of charge? That was meant for you to, pause and think of the answer. So you're just waiting for me to think for you. Oh, and Aaron, of course, I'm sure, has an answer. So the pith ball thinks it has a negative charge, and I'm too lazy to write the word negative. You get to write it down. It thinks it has a negative charge. It's attracted to this positively charged object. So draw the charges in each of the objects. There, I'm showing in this arrow, it's neutral but polarized. I suppose if I zoom in some more, you can see I drew a neutral but polarized Cheerio by the plastic pipe. Next step. So this is sequential. Before anything happens, when I bring the rod near the Cheerio, and now they attract and touch. When the objects come into contact, what happens? Okay, you should say electrons transfer. Never tell me that a positive charge goes anywhere. What do the charges do in the pith ball? Oh, yeah, what do the charges do in the pith ball? I'm going to write electrons leave. And not all of them, please. Not all of them. Some electrons leave. So what type of charge does the pith ball have afterwards? And so in this drawing, I'm going to show the action activity that is an arrow with electrons leaving the Cheerio and going onto the irrigation pipe. Okay, so this thing was neutral but polarized. This thing was positively charged, and I only ever drew 2 plus signs on it, which I almost regret now because I just drawn 2 electrons on it. And you can say, oh, look, it canceled. I didn't draw the actual number of electrons. It's trillions, by the way, or trillions upon trillions. It's a lot. I'm not going to draw them. So the point that I want to make is just like the foil with the balloon and even some of the paper confetti that got lucky with the balloon, when it just so happens that the neutral object hits a charged spot and the electrons can manage to transfer, even though that's an insulator and this is an insulator, and the electrons are having a very hard time in being free to move. Remember, we rubbed on it with friction, and that enabled the electrons to move between the wool and the pipe. So now I've got this charged pipe, I've got a neutral pith ball, initially Cheerio, that moves towards it. If it gets lucky, then the charge will transfer. If it's not so lucky, then they're just wanting to transfer all the time. And that is where you see the Cheerio is stuck to, great, now it doesn't do it, where it was stuck to the PVC pipe, okay? But just like the aluminum foil, just like some of that paper confetti, this thing is given some electrons, but not as many as this thing wants. So same numbers. Let's say this thing has a positive 500 charge on it, that it's lost 500 electrons. And this Cheerio gave it 20. Well, great. That means that the Cheerio is now positively charged. And I have a positively charged pith ball, and I have a less positively charged pipe. I'm only drawing one plus, but out of 500, I've just gained 20 electrons, so I'm down to only 480 plus signs to draw, as a quantitative number for this. So I've drawn one of the 480 plus signs, and they're like charges. So what does the pith ball finally do? It repels. And so when they separate, I've got like charges repelling. Here are the three ways that a neutral object can become charged. The first method is charging by induction, and I didn't make it too clear how it can end up being charged. So I should give you a visual example. I will do it just by drawing on paper. Suppose I have two Cheerios, or better yet, two metal spheres. Much better than a Cheerio, pair of Cheerios, as far as illustrating the concept. And nearby, I bring a charged object. Now, it could be a positively charged balloon, could be a positively charged pipe, doesn't matter what the charge is. Let's say it's positively charged. Okay, so I bring this positively charged object near a neutral object. It becomes polarized. The electrons, in this case, move towards the charged object. I suppose I should zoom in more on my excellent drawing and say, great, the electrons pile up on the near side, the protons are left behind on the far side, and these are, overall, this is a neutral object. Now let's say each one is hanging by a thread, like here. But what I do is I now pull on one of them and I separate them from each other. So imagine if I had two Cheerios, they were touching each other, I bring the rod nearby, and what happens is they become polarized. And now I pull the back one away from the near one. Oh, I've lost my thread. Time to stop teaching. So here's the after picture, crudely drawn. This never touches anything, is the idea here. So this was a charged object, and it remains with the same amount of charge it had to start off with. So if it was a plus 500 charge, it's still a plus 500 charge. And now what I have is the near object is no longer touching the far object. So the electrons are trapped on the near object, which I just drew with a plus sign. Sorry. Well, another mistake. So the electrons are stuck on the near object, and the protons are left behind on the far object. These now have equal quantities of electric charge. And generally, they're both going to be weaker than the nearby charging object. So if this has a plus 500 charge, then there's no way this thing is going to end up with a minus 600 charge. It's going to be less than 500. And here, the far object, remember, these were both neutral initially. So for every electron that goes to here from there, the change in charge is identical for the two objects, just opposite in sign. So if this thing ends up with 200 electrons on it, it ends up with a minus 200 electrical charge, and this thing has a corresponding positive 200 electrical charge. For every electron that leaves here, this becomes positive by the same amount this becomes negative. And both of these are going to be less than whatever the charge was on the nearby object. So this is what is meant by charging by induction. It means that the charging object itself does not directly contact that which ends up becoming charged. The second method of charging is charging by conduction. Charging by conduction means the charged object actually touches the object that becomes charged. So direct transfer works best when you are talking about a conductor and another conductor. So if I had foil and a metal sphere and I touch them to each other, they're going to transfer charge and both become the same type of charge. So in charging by conduction, the resulting object takes on the same sign charge as the object that that touches it. Okay, so same sign. So if this is positive, then the new object also ends up being positive. There's my great shorthand way of telling you that if I start with a positively charged object, I end up with another additional same charge, same sign charged object. Induction, I end up with a pair of oppositely charged objects. There is a third way called charging by grounding induction, where I end up with a negatively charged object and Mother Earth, which is considered neutral, but it's going to be opposite of what I start with. And then the third way, we didn't put a name to it, but on this back side of the worksheet, we did charging by friction. So when you rub objects against each other, you're giving energy to the electrons enough so that they could transfer from one material to the other. Think way back to the tape lab, where the idea was when you rip the tape off, the electrons have the opportunity to go to the lowest available energy state of the two materials. That's what's going on when you charge by friction here. So for the third method of charging, I would put down the word friction, charging by friction, or if you need a reminder, by rubbing one object against the other, charging by friction, charging by rubbing, you're scraping electrons off of one neutral material and onto the other neutral material. These both began as neutral objects. That's different from charging by induction. That's different from charging by conduction. This is charging by friction and plays into more of our study of electrostatics. For now, I think this is long enough of a video, and so I say ciao for now.